Hello everyone, I am Raju in class number 8. I am an aeronautical engineering student and today we are discussing about reflection of cantilever beam used in aircraft and for antenna mounting. So here we go. So according to our domain, the antenna of the aircraft is lighter in weight and it is sustainable. So it carries on the fuselage and hinge of the aircraft. Cantilever beam is fixed on the cantilever structure, which is like fixed in one side one load is applied. Hence the antenna must be have sustainable. So this is our introduction to this topic, and the key design of the minimum deflection of and vibration of the antenna have must be done. So next slide. Here are the fundamental principles of beam deflection and antenna deflections. Like beam deflection is the displacement of the structural elements under the applied load. When the load is applied on the one side of the cantilever beam, there is a applied of the force and it is bent, like one side is bended. So that is the case for the antenna. Here the excessive deflection, loose antenna and alignment performance decreases. Then here are the formulas: g square by d square dx square, mx ex. Here is the mx is a bending moment and e is a modulus of elasticity. I is a moment of inertia. Here are the deflection formula for the point of the load of the free end. Rho is equals to P into L cube by 3 E into I. E is the modulus of elasticity and I is the moment of inertia. E is the length. For the cantilever beam analysis in the antenna, there is the movement of the one side like free end. Here we can understand what with the figure. The load scenario, aerodynamic drags it flow force of the airflow. It affects on the inertial force during the aircraft is moving in the air. Antenna observes the vibrations and drag force. So it bends one sidely, and the deflection character, maximum deflection occurs on the end of like free end. So directly proportional to load and tube length. When the load is maximum, the deflection also maximum, and the stiffness is maximum, the deflection is minimum. Here are the materials which are used in antenna, making of antenna. We can use aluminum, titanium. They are highly stainless in weight ratio. They are strong but lightweight. That's why we can use it. Composition materials like carbon fibers, rigorous polymers. It is of 40 to 60% weight, saving high resistance. Then cross-sectional chooses tubular and rectangular section perform the antenna mats like section like this, rectangular or tube shape. Like that shapes also reduce the deflection of the antenna. Key factors in maintaining structure without existing allowables. Deflection limit is 5 to 10 mm stability. Next slide. Here are the special applications in aircraft antenna mounting. Here we can see Boeing 787 antennas, more than 10 antennas on it, and they are also made of lightweight materials like aluminum and titanium. The uses of the communication, the antenna, wave, radar, and navigation sensors placed on the fuselage or the tail of the aircraft, and they are also a strong cantilever design. In deflection control ensures stable antenna organization. Then load case. In load case there is taking off and taxi. Vibration and drag force will apply on these antennas. Cause continuous aerodynamic load. In the air there are the aerodynamic load and airflow. There is the forces acting on the antennas. That's why the reflection happens. And to the dynamic oscillation of loads. In next slide, here are the cataract reflection issues and failure modes. Like excessive bend causes mind lesion and reducing single qualities. Vibration resonance, like natural frequency overlap with the aerodynamic resistance. Bilk rates, like thin walled components, like this thin walled components are mounted by the bulbs. Like here we can see the thin walled components are there, placed there. Then next slide. Modern approach and solutions, like components and the resonance, carbon carriers and weapon with the reduce the weight. Here are the components like cured fibers are the weight taking carbon fiber. They can reduce the weight of the antennas. In vibration decomposition, there we can use rubbers and viscosity mounting resistance the oscillation of the antenna. The antenna is oscillate like in this way. So we can reduce the oscillation of the antenna with the rubber, help of the rubber. Also in smart structures, inner sensors for the real-time reflection mounting. Design goes highly stiffness to weight ratio with the filling resistors. Reference of the case study examples. Here are the case study example. The tail of the antenna is VFF antenna, and the load applied is 50 Newton aerodynamic thrust, and drag is the 0.7 cantilever length. So we can see here the reflection, and the mainly antenna is material usually is aluminum tube, and the is 7 GK and length is 2 into 5 meter cube. Then we can apply the formula rho is equals to this one formula. We can get the value of the reflection. This is the total reflection, and the case study is reference to the megason and peak aircraft structure for the engineering students. It is made for engineering students, and NASA technology reports, like I take reports from the previous years of the NASA, and then I make this analysis of the mounting of reflection of antenna. So thank you.